Lecture 9-5, Geological Time. Using various techniques, talking about absolute dating, scientists have determined an age for the Earth and a timeline for what happened and approximately when. It's a combination of all the absolute dating with the relative dating, using different radioactive materials to identify the ages of rocks on the Earth, coming up with an age for the Earth. The Earth is 4.6 billion years old. Now, give or take, I think it's half a billion years. So that places the Earth as a very old object. It's just a little bit younger than the formation of the solar system. So it's a very old object. We divide that 4.6 billion years into 4 eras. Eras are the big time periods. The Precambrian is the first one, Paleozoic second, the Mesozoic third, and the Cenozoic is the fourth, and this is the current one we are in. Each era then is divided up into periods. We are in the Quaternary period of the Cenozoic era. So there's all the time, all 4.6 billion years. We break down 4 eras and break those eras down to periods. Now there are different ways we could break down the time. There are generally a couple different systems people look at, but the main one, you deal with 4 main areas. Now, the Paleozoic is divided up into the Cambrian, Ordovician, Silurian, Devonian, Carboniferous, and Permian periods. The Devonian is actually a very important one because when we talk about the fossil gorge in Iowa City, just north of Iowa City, part of the Coralville Reservoir, those fossils are all from the Devonian time period. They were all laid down, they all died in the Devonian period, so that tells us how old they are. So that's a term we hear a lot in when you're talking about fossils in Iowa, especially Devonian and Silurian. Those being the main ones. Mesozoic contains the Triassic, Jurassic, Cretaceous periods. A lot of people will think about this as the age of dinosaurs. The Cenozoic, and again, that's what we're currently in, is broken down to the Tertiary and Quaternary periods. Now, this is kind of a scaled representation of the 4.6 billion years. It's actually not perfectly to scale, and that's why you'll be doing a scale activity in class. But it's easy to see that the Precambrian easily occupies the majority of the time of the Earth. That's just because it took a long time. We identify the eras mostly by the organisms that lived during that periods. And so the Precambrian era is going to contain the most because it took the longest for complex organisms to form. And then the Paleozoic was longer, Mesozoic a little bit shorter, and then Cenozoic is the shortest of all. So Precambrian is the longest, Paleozoic is just a little bit shorter by a lot. Mesozoic shorter than the Paleozoic, Cenozoic one we're now is the least. And you can see how the then periods are broken down in the order that they are. We'll be doing more of this with the geological timeline. And again, the big difference that we look at with these eras and periods is going to be the organisms that were around during that time, the predominant organisms, the plants and animals. You can see that during the Paleozoic, we had a lot of sea creatures, a lot of more primitive life forms. The Mesozoic, we can identify with the age of the dinosaurs, and the Cenozoic is the rise of mammals. But you can see that we broke these down, and if you look at each period, you can see the different organisms that live then, and we start to look at why. And the Earth is different during each of these periods. During the Jurassic, it could be a lot warmer. We could think back to what could cause that. Jurassic occurred for 46 million years. Cretaceous, 62 million years. Pretty much the Quaternary is just within the last million years or so. And that's what we identify each of these by the organisms that live there. Now again, using various techniques. It's not just one technique. It's how we came up with the 4.6 billion years. And there is error built into any technique. But it's the fact of the matter that we've used so many different techniques, they all come up with the same age, that 4.6 billion years is a very confident number for the age of the Earth.